In this episode, which is the final one of this overhaul, we're gonna look at the reed valves and how to adjust them so that they close tightly. The problem with this engine is that it's hard to start, so checking the reed valves is necessary. The operation is also quite easy. The hard part is to get to the reed valves. To do that, you need to actually unbolt the whole engine and lift it out of the chassis. That is a smaller Yamaha, a 2 horsepower 2-stroke. And the location here is Stegeborg, which is in the eastern part of Sweden, 200 or so kilometers south of Stockholm. And now back to the workshop. If the reed valves need to be adjusted again, it's gonna be the same hard process of removing the engine yet again. So I decided to drill holes instead in the side to get to the reed valves fast and easy. And in this video I will show you how I did that. So starting to removing all the screws here. Some of them are easy, but as you can see, some of them are blocked by the side. In this model, the 6A, the carburetor is standing on top of the reed valve. And that means that the intake needs to go down below the side of the engine and thus blocking all the screws. The main difference between model 6A and the 6B model is actually how the carburetor and the reed valves are configured. As you can see in the picture here, the reed valves on the 6B model is actually mounted on the side and is very easy to get to. I suspect you just remove the carburetor and you get to the screws for the reed valve immediately after. In the 6A, however, you can see that the design is really bad and the screws are really hard to get to. I've actually never seen anything like it. It's absolutely stupid. And it's hard to imagine this is a Yamaha engine. It's also quite obvious that the reed valve is actually one of the main maintenance items you need to get to once in a while to make sure that the engine is operating perfectly. So how is it possible that Yamaha decided to put the reed valve below the side of the engine so that you need to lift the whole engine out of the chassis to get to the reed valves? It's quite amazing actually. And this must be one of the worst, most stupid engines that Yamaha has ever produced. I did not expect this from Yamaha actually. And I should have checked this before I bought the engine. But now this is how it is and we need to get to the reed valve, so there is not much to do than to bring out the big drill and drill bits and start drilling. You only get one chance when drilling, so it's quite imperative to choose the correct drill bit from the start. And it can also be wise that if in doubt, just choose the bigger one. When working around boat engines and the boat of course, I find it quite handy to have the Victorinox skipper always around. The pliers on the Victorinox skipper and all other Victorinox multi-tools are actually the best pliers for some tasks that you can find. They're very precise and you can use them in a lot of different scenarios. The side of the engine is made of aluminium, so it's quite easy to drill into. Once again, you only get one chance to drill the hole, so choose a drill that is large enough from start. And if in doubt, just choose a bigger one, not the small one. I've had a lot of use of these drill bits and they're not that expensive. I bought them off Amazon a year ago or so, and I've been using them frequently. The holes are not that pretty to look at, but I'll try to cover them up somehow later. And it's also quite convenient to have them there so that you can access the reed valve again later if needed. This one is not tightened and has likely been this for many years, or since the start. So this bolt should of course have been tightened. If not, that might lead to some serious vacuum issues and an engine that is hard to start. And that is exactly what's the problem with this engine, is that it's hard to start. So that could actually be one of the reasons for that. Here you can see the valve with the two paddles, and I suspect that the top one in the picture is not sealing as well as the bottom one. It's also possible to see a faint light coming through the top paddle when shining a light from the other side. So I tried to just flip it around first to see how it looked like after that. I also did bend the paddles a bit in the end to get them to seal tightly. I had no success finding the right gasket to this engine. There are a lot of gaskets for the 6B version, but the 6A I couldn't find anything. Luckily enough, I had some gasket paper at home, and I then started making gaskets on my own. First I did a gasket in 0.4 millimeters, but that was too thin, so I used 0.8 millimeters in the end for all gaskets. This kind of work turned out to be a really good match for the small pen blade of a Victorinox knife. The tip is rounded, and so it rides on the paper better when cutting like this, in contrast to a scalpel that would dig down. So when comparing cutting the gaskets between this pen blade and a scalpel, I found that this one was much more suited for the task of cutting through thick gasket material. The problem with this pen blade, however, is the exact same problem as with all other Victorinox Celador knives, and that is that the knife blade is not locking. Neither the small pen blade nor the big main knife blade are locking. But as I will show you now, there is a very easy way to lock the small blade. And I suspect strongly that I might be the first person to lock the blade in this fashion. So the amount of force you can apply on the blade backwards is of course dependent on how strong this metal is in the rings. But I found that you can put a lot of pressure on those rings, and those two being just standard rings I found in a box at home. So I would say that that pen blade is quite safe with that solution. Even if you use the pen blade to like push into a material with the points straight in and drilling, that would not be possible without locking, thus the blade would fold immediately. As you saw there, I had to trim the edges of the gasket a bit to get a perfect fit. This is the other part of the reed valve with two pedals, and this is for the lower cylinder, cylinder number 2. So this configuration is actually stacked with the inner reed valve and outer reed valve, and both need to seal, of course. I mean, comparing this design to the one of the 6B I showed you previously it's quite amazing how bad this is. There are so many seals, and the seals are much bigger than the newer version. Many points where vacuum issue could occur. And the serviceability and maintainability of this engine is really bad. And when looking for parts on the internet, and I couldn't find much. I couldn't find anything at all actually. And I suspect that these engines have all been scrapped, and probably due to this non-existent maintainability issue of the reed valve, because it takes so many hours to just fix this on this engine. And just comparing it to the 6P, I mean, normally you would just throw this engine away and buy a newer one. When counting the number of gaskets you need to change, I get the number to like 4 or maybe 5 different ones. And all of them are impossible to find and buy, so you have to manufacture all of them. And when doing that, you really need to take a picture of the old gasket when disassembling the engine, since there are small holes and canals in different places where you need to know if they need to should be opened or if they could be closed by the gasket. Some of the canals and throw holes on the original sealings actually were closed by the sealing, which was still intact. So I've tried to copy that as good as I could with the new sealing as well. And of course there is no documentation or IPC or anything to this engine. The oldest IPC illustrated parts catalog I could find was for the 6B. And that is the sequel to this engine, of course. And that catalog, the IPC, I couldn't find online. I had to contact the dealer to send it to me. My recommendation if you're into two-stroke engines is to avoid the 70s and maybe 80s as well, and try to get the 90s engine instead, just for the availability of spare parts catalog and spare parts. So this is final assembly of the cleaned up carburetor. In the beginning of this video I said that this would be the last video, and it's part 4 and the last part actually, but there will be a part 3 as well on the carburetor cleaning and changing of the gaskets there. And since I noticed that there is a leaking gasket in the carburetor, I need to change that before I can start up the engine. So stay tuned for part 3 and the startup of this engine. So this is the final result with all the holes and the new gaskets on the reed valve. Not pretty, of course, but convenient. Now, when I need to open this up again in like 30 years, it will be much faster. Thank you for watching and stay tuned so you don't miss my next video.